Basic operations in functions. We have addition and subtraction in functions. Two or more functions can be added or subtracted to give rise to another function. For example, if f of x and 2x are two functions, then it is possible to have another function h of s such that h of s is equal to the sum or the difference of f of x and g of x. For example, if f of s is equal to 3x plus 5 and g of x equal to 1 minus x squared, find f of x plus g of x and also find g of x minus f of x. Solution: f of x plus g of x would give us 3x plus 5 added with 1 minus x squared. This will give us 3x plus 5 plus 1 minus x squared, which will give us 6 plus 3x minus x squared. Whereas g of x minus f of x will give us the value of g of x minus the value of f of x, which is 1 minus x squared minus 3x plus 5. This will give us 1 minus x squared minus 3x minus 5, which will give us minus 4 minus 3x minus x squared. Multiplication and division in functions. Two or more functions can be multiplied or divided provided the divisor is a non-zero function to give rise to another function. If f of x and g of x are two functions, then it is possible to have another function h of x such that h of s is equal to the product of f of x and g of x, or h of x will give us f of x divided by g of x provided g of x is not 0. For example, if f of x is 3x plus 5 and g of x is 1 minus x squared, find f of x, g of x, and also find g of x divided by f of x. Now, solution: f of x multiplied by g of x will give us the value of f of x multiplied by g of x, which is 3x plus 5 being multiplied by 1 minus x squared. This will give us 5 plus 3x minus 5x minus 3x cubed. For g of x divided by f of x, we will have g of x divided by f of x equal to 1 minus x squared divided by 3x plus 5, provided that 3x plus 5 is not 0, or x is not minus 5 over 3. Composite functions. Just imagine a composite function as a lump of chicken x, which has to go through parboiling f of x before frying g of f of x. For example, if f of x is equal to x plus 1 and g of x is equal to 2x, then g of f of x simply means 2 into f of x, which is equal to 2 into x plus 1, which is 2x plus 2. Otherwise, you can factor out 2, you have 2 into x plus 1. Another example: if f of x equal to 1 minus x raised to the power of 2 and h of x is equal to 2 plus x, and we have g of x equal to x raised to the power of 3, evaluate I, g of f of 2, g of 2 multiplied by f of 2, f of h of g of minus 1. Now, solution: g of 2 is a composite function, so we start by calculating f of 2, which gives f of 2 equal to 1 minus 2 raised to the power of 2, which is 1 minus 4, which will give us minus 3. Then, clearly, g of f of 2 becomes g of minus 3, which is equal to minus 3 raised to the power of 3, which will give us minus 27. Therefore, g of f of 2 is equal to minus 27. In II, g of 2 f of 2 is a product of two valued functions under x equal to 2. Then, first thing, we calculate g of 2, which will give us g of 2 equal to 2 raised to the power of 3, which is equal to 8. And f of 2 already is calculated as 1 minus 2s squared equal to 1 minus 4 equal to minus 3. Clearly, g of 2 multiplied by f of 2 will give us 8 multiplied by negative 3, which will give us negative 24. I, f of h of g of minus 1. We start by calculating g of minus 1, which will give us minus 1 raised to the power of 3, which is equal to negative 1. Then we calculate h of g of minus 1, which is h of minus 1, because g of minus 1 is minus 1. So h of minus 1 will give us 2 plus negative 1, which is equal to 1. Then we calculate f of h of g of minus 1, which is f of 1, which will give us 1 minus 1 squared, which is 1 minus 1, which will give us 0. Therefore, f of h of g of minus 1 is equal to 0. Inverse function. The inverse function f of s is clearly another function, say g of s, which returns the object x. As an example, consider the real valued function of a real variable given by f of s equal to 5x minus 7. Thinking of this as a step-by-step procedure, namely, take a number x, multiply it by 5, then subtract 7 from the result. To reverse this and get x back from some output value, say y, we should undergo each step in reverse order. In this case, that means we should try to add 7 to y and then divide the result by 5. In functional notation, this inverse function would be given as g of y equal to y plus 7 divided by 5. With y equal to 5x minus 7, we have that f is equal to y and g is equal to s. Not all functions have inverse function. Those that do are called invertible. For a function f under x implies y to have an inverse, we must have the property that for every y in the set y, there is 1 and only one x in the set x, so that f is equal to y. This property ensures that a function g of y implies x exists with the necessary relationship with f. Clearly, g of x equal to x plus 7 over 5 is called the inverse function of f of x, equal to 5x minus 7. More example on this. Let us consider the function f of x equal to 3x minus 1 all over 2x plus 1, where 2x plus 1 is not equal to 0. Let us try to find the inverse function of f of 2. Now, first of all, the first step is for us to set f of s equal to y and make s the subject formula. Y is equal to 3x minus 1 all over 2x plus 1. By cross multiplication, y multiply 2x plus 1 is equal to 1 multiply 3x minus 1. If we multiply y into, we have 2xy plus y equal to 3x minus 1. Then we collect like terms. We have 3x minus 2xy equal to y plus 1. Make x the subject formula. We have x equal to y plus 1 over 3x over 3 minus 2y. Second step is to replace f inverse of x wherever we see x, and replace y to x wherever we see y. Therefore, we have f inverse of x as x plus 1 all over 3 minus 2x. The third step now is for us to find f inverse of 2 by replacing s equal to 2 in f inverse of x. Therefore, f inverse of 2 will give us 2 plus 1 all over 3 minus 2 into 2, which will give us 3 over 3 minus 4, which will give us 3 over negative 1, which is equal to negative 3.